See here in the complex numbers, first we define a quantity called I square is equal to minus 1. I is equal to root of minus 1. We define a quantity called I square is equal to minus 1. I is equal to root of minus 1. See, the purpose of defining I square is equal to minus 1 is to evaluate square roots of negative real numbers. See, for example, let us say you come across square root of minus 4. In the real number field, we will say that it does not exist. See, when you know only real numbers, your concept is what? It does not exist. Because square root of a negative real number does not exist. But when you go for complex numbers, we can write like this. This is square root of 4i square, which is equal to plus or minus 2i. So, in order to define square roots of negative real numbers, we introduce a quantity called I square is equal to minus 1, where I is equal to root minus 1. Understood? Now, a number of the form z is equal to x plus iy, where x comma y are real numbers, where x comma y are real numbers is called complex number, is called complex number. So what is a complex number? It will be in the form of x plus iy, where I square is equal to minus 1. X and y happens to be real numbers. So such type of numbers are called complex numbers. X is called real part. X is called real part. Y is called imaginary part. Y is called imaginary part. So real part usually we write RP, imaginary part we are going to write it as IP. So a number of the form z is equal to x plus iy is called a complex number, where x and y are real numbers. X is called real part of the complex number and y is called imaginary part of the complex number. For example, 3 plus 4i, 6 minus 2i, root 2 plus root 3i, 1 plus root 2i, minus 1 by 2 plus I by 3. So these are all examples of complex numbers. So in this complex number, 3 is real part, 4 is imaginary part. 6 is real part, minus 2 is imaginary part. Root 2 is real part, root 3 is imaginary part. Like that, you have to identify the real part and imaginary part of a complex number whenever a complex number is given for you. So this is the definition of a complex number. Then the next point is equality of two complex numbers. Equality of two complex numbers. Equality of two complex numbers. See, equality of two complex numbers means when do you say two complex numbers are equal? Let us consider z1 is equal to x1 plus iy1, z2 is equal to x2 plus iy2 like this. If z1 is equal to z2, if these two are equal, then x1 is equal to x2, y1 is equal to y2. So if two complex numbers are equal, then their real parts must be equal, imaginary parts must be equal. So if two complex numbers are equal, real parts are equal, imaginary parts are equal. So this is equality of two complex numbers. So when two complex numbers are equal, the real parts must be equal, their imaginary parts must be equal. Suppose let us say x minus 2 plus I into y minus 3 is equal to 4 plus 3i. Find the values of x and y. Then it is very simple. X minus 2 must be 4, y minus 3 must be 3. X is equal to 6, y is equal to 6. So like that, you can equate the two complex numbers. So I am once again repeating the point. Two complex numbers are equal provided their real parts are equal, their imaginary parts are equal. See, the set of complex numbers will form a non-ordered field. See the points, just see field, ring and all those things, they are all definitions of modern algebra. That is not necessary. You just remember one simple point here. Set of real numbers will form ordered field. See, set of real numbers will form ordered field means you can put real numbers either in the increasing order or in the decreasing order. If two real numbers A and B are given, you can easily tell whether they are equal or one is less than the other. I mean, if A and B are real numbers, we can say whether A is equal to B or not, or A less than B or A greater than B or not. That means two real numbers can be compared. Right? If there are two real numbers, either both of them will be equal or one will be less than the other. This definitely happens in the case of real numbers. But in the case of complex numbers, you cannot compare like that. You cannot compare like that means if Z1 and Z2 are two different complex numbers, you cannot say Z1 less than Z2, Z1 greater than Z2 like that. That means comparison of two complex numbers is not there for us. Yes, right. So, in the case of complex numbers, comparison is meaningless. I mean, Z1 less than Z2 is meaningless. Is meaningless in the case of complex numbers. Similarly, Z1 greater than Z2 is also meaningless. So, two complex numbers can never be compared. Write down the point. Two complex numbers can never be compared. Like Z1 less than Z2 is not meaningful. Z1 greater than Z2 is also not meaningful because set of complex numbers will form a non-ordered field. In the case of ordered field, you can compare that you have seen in the real numbers. In the case of complex numbers, two complex numbers can never be compared. Yes? The next point is addition of complex numbers. Addition of complex numbers. Addition of complex numbers. See, if there are two complex numbers, Z1 is equal to x1 plus iy1, Z2 is equal to x2 plus iy2. Let us consider two complex numbers like this. Then Z1 plus Z2 means you add real parts and correspondingly imaginary parts. So in order to add two complex numbers, you have to add correspondingly real parts and correspondingly imaginary parts like this. So Z1 is equal to x1 plus iy1, Z2 is equal to x2 plus iy2, Z1 plus Z2 is equal to x1 plus x2 plus I into y1 plus y2. Similarly, Z1 minus Z2 is equal to x1 minus x2 plus I into y1 minus y2. So Z1 minus Z2 is equal to x1 minus minus x2 into plus I into y1 minus y2. For example, z1 is equal to 3 plus 4i. z2 is equal to 5 minus 2i. Let us say I want z1 plus z2. So 3 plus 5, 8 plus 4 minus 2, 2. Like this. I want, let us say, z1 minus z2. z1 minus z2 is 3 minus 5 minus 2. 4 minus half minus 2 plus 6. Like this. So addition of two complex numbers can be done like this. Right? The next point is multiplication of complex numbers. Multiplication of complex numbers. Multiplication of complex numbers. Listen. Suppose z1 is equal to a plus ib. z2 is equal to c plus id. z1 into z2 is equal to a plus ib into c plus id. You have to just multiply like a plus b into c plus d form. So when you multiply a into c plus I into AD plus I into BC plus I square BD. You will get like this. This is AC, I square is minus 1. So AC minus BD plus I into AD plus BC. So Z1 into Z2 calculation can be done like that. So if Z1 and Z2 are two complex numbers, in order to multiply them, we follow this procedure. You have to just blindly multiply just like real numbers, but the problem is, wherever you get I square, you write it as minus 1, then you will get like this. Segregate real parts, segregate imaginary parts and put it like this. This is how you are supposed to multiply two complex numbers. We will do one numerical example. Z1 is equal to 3 plus 4i. Z2 is equal to 5 plus 2i. Z1 into Z2 means 3 plus 4i into 5 plus 2i. This is equal to 15 plus 6i plus 20i plus 8i square. I square is minus 1. So 15 minus 8 I into 6 plus 20. 7 plus 26i, like this. So two complex numbers can be multiplied like this. So in order to multiply two complex numbers, this is the procedure. Next is multiplication of complex number. Multiplication of complex number. Multiplication of complex number by a real number. By a real number. Suppose let us say z is equal to x plus iy. K is a real number. What is kz? Kz means k into x plus iy, which is equal to kx plus I into ky. That's it. Just multiply real part and imaginary part. For example, z is equal to 3 plus 4i. What is 5z? 15 plus 20i. Multiply both of them with what? 5. So 5z is equal to 15 plus 20i, like this. So in order to multiply a complex number by a real number, you have to think like this. Let us say z is equal to x plus iy, where k is a real number. Kz will be k into x plus iy, which is equal to kx plus iky like this. So this is multiplication of a complex number by a real number. Next point is, suppose if a complex number z is equal to 0, then x plus iy is equal to 0 means x is 0 and y is 0. X is 0 and y is 0. So, if a complex number is 0, real part must be 0 and the imaginary part must be 0. So, if a complex number is 0, real part is 0 and imaginary part is 0. The next definition is conjugate of a complex number. The next definition is conjugate of a complex number. Conjugate of a complex number. See, conjugate of a complex number, we define it like this. If z is equal to x plus iy, then z bar is equal to x minus iy, and z bar is called conjugate of z. See, z is equal to x plus iy, we define a complex number z bar which is equal to x minus iy, and z bar is called conjugate of z. Z bar is conjugate of z, and z is conjugate of z bar. So z and z bar are called together conjugate complex numbers. So if you are considering x plus iy, x minus iy is conjugate. If you consider x minus iy, x plus iy is conjugate. So conjugate of z is z bar, conjugate of z bar is z. So z and z bar are called conjugate complex numbers. So if z and z bar are like that, then what is z plus z bar by 2 is equal to x? Correct? Add both of them. So this is real part of z. What is z minus z bar by 2 y, which is imaginary part of z. This plus this means iy will cancel. So x you will get this plus this by 2. That is real part of z. This minus this will give you 2iy. By 2i will give you y. So that is your imaginary part of z. Right? So z plus z bar by 2 is real part of z. Z minus z bar by 2i is imaginary part of z. So this is a definition of a conjugate complex number. Now, for example, let us consider z is equal to 3 plus 4i. What is z bar? Z bar is equal to 3 minus 4i. What if z is equal to 2 minus i? What is z bar for you? 2 plus i. So if a plus ib means a minus ib you should consider. So if z is this, z bar is equal to this. If z is this, z bar is equal to this. Now listen. You should remember certain properties regarding the conjugates. So there are here first I am going to tell you some simple properties. Later on, after defining some more definitions, we will extend the properties of the conjugate complex numbers. At present, in the beginning, you should remember the following points. Z bar whole bar is equal to Z. See, conjugate of conjugate is itself. Z bar of whole Z bar is equal to Z. Suppose let us say Z is equal to 3 plus 4i. Z bar is equal to 3 minus 4i. Z bar of this is nothing but what? This, which is Z itself. So Z bar of bar is equal to Z itself. The second property is Z1 plus Z2 whole bar plus or minus is equal to Z1 bar plus or minus Z2 bar. Z1 plus or minus Z2 bar is equal to Z1 bar plus or minus Z2 bar. For example, let us consider you are having 3 plus 4i, 6 plus 5i whole bar. This is equal to 3 plus 4i bar plus 6 plus 5i bar, which is 3 minus 4i plus 6 minus 5i. So conjugate of sum is sum of their conjugates. Conjugate of conjugate is itself. Conjugate of sum is sum of their conjugates. You can extend this property like this. Z1 plus Z2 plus Z3 up to Zn whole bar is equal to Z1 bar, Z2 bar, Z3 bar, Z4 bar, Zn bar like this. So conjugate of sum is sum of their conjugates, right? See, the next property is the third property. Z1, Z2, Z3, etc. Zn whole conjugate is equal to Z1 conjugate, Z2 conjugate, Z3 conjugate, Zn conjugate. See, the meaning of this statement is like this. The meaning of the statement is 3 plus 4i into 6 plus 5i into 10 minus I whole conjugate is equal to 3 minus 4i, conjugate of this. What is conjugate of this? 6 minus 5i. What is conjugate of this? 10 plus I. You can write like this. So conjugate of this into conjugate of this into conjugate of this. You can write like that. The next property is Z1 by Z2 whole conjugate. Z1 conjugate by Z2 conjugate. Z1 by Z2 whole bar is equal to Z1 bar by Z2 bar. Now, for example, let us say you are having 3 plus 2i by 1 plus I conjugate you want. Then you can write 3 plus 2i conjugate by 1 plus I conjugate. So 3 minus 2i by 1 minus I. You can put it like this. Now, in order to sum up all these things, let us consider you come across a case like this. Z is equal to 2 plus 3i into 4 plus I by 6 plus I into 1 plus 2i like this. My question is, what is Z bar? Find Z bar. So find Z bar means Z bar is whole conjugate of this. So 2 plus 3i into 4 plus I by 6 plus I into 1 plus 2i whole conjugate, which is equal to 2 plus 3i conjugate 4 plus I conjugate by 6 plus I conjugate 1 plus 2i conjugate, which is 2 minus 3i into 4 minus I, 6 minus I into 1 minus I. Understood? So Z bar can be estimated like that. So this is regarding some preliminary properties of conjugate complex numbers. So conjugate of Z is Z bar. If Z is in the form of x plus iy, Z bar is in the form of x minus iy. Right. So based on all these things, we will try to follow some problems regarding the complex numbers. The first question is, Z is equal to 3 plus 4i, Z1 is equal to this. Z2 is equal to 4 minus i by 3 plus 3 not 2 plus 3i, let us say. I want you to calculate Z1 plus Z2. Z1 by Z2. Z1 into Z2. I want you to do all these manipulations. See, whenever you get a quotient like this, what we are going to do is, we try to make this as a real number by multiplying with the conjugate. So 3 plus 4i by 1 plus i. You multiply with the conjugate. You multiply with the conjugate. Then you are going to get 3 minus 3i plus 4i minus 4i square by a plus b into a minus b is what? A plus b into a minus b is a square minus b square. A square is 1 square minus I square. This is I square is minus 1. So you will get 7 plus I by 2. So Z1 is equal to 7 plus I by 2 you will get. Similarly, you make Z2 also like this. 4 minus I by 2 plus 3i. Multiply with the conjugate of denominator above and below. You will get 8 minus 12i minus 2i plus 3i square by 2 whole square minus 3i whole square. So this is equal to I square is minus 1. So you will get 5 minus 14i by 4 plus 9. Because you will get minus 9i square. I square is minus 1, therefore plus 9. So 5 minus 14i by 13 you will get. So once you make the denominator purely a real number, then Z1 plus Z2 is equal to 7 plus I by 2, 5 minus 14i by 13 like this. You can have LCM 26, 91 plus 39 plus 10 minus 28i like this. So 91 plus 10 is 101 minus 15i by 26. 101 minus 15i by 26 you will get. That is how Z1 plus Z2 can be estimated. So whenever two complex numbers are given, whenever you want to do this type of manipulations, you are first advised to make the denominator real. To make the denominator real, you just multiply with the conjugates. Conjugate of 1 plus I is 1 minus I. Then simplify like this. Then Z2 also simplify like this. After simplifying, then try to take LCM. Don't try to take LCM between two complex numbers. That is foolishness. You will go wrong. You will have calculation mistakes. Convert into purely real like this, then you proceed in this manner. The next calculation is Z1 by Z2. Z1 is 7 plus I by 2. Z2 is 5 minus 14I by 13. This is as good as you can put 7 plus I by 5 minus 14I into 13 by 2, is it not? Now you have to put like this, 13 by 2 into, you rationalize the denominator, multiply with 5 plus 49. 7 plus I into 5 plus 49 like this. So when you simplify this, you are going to get 35 plus 98I plus 5I plus 14I square whole divided by, this is, shall I write directly, a square plus b square plus 196 into 13 by 2. Now I square is minus 1, 35 minus 14 is how much? 35 minus 14 is 21 plus 103I by, this is 121 into 13 by 2. This is how Z1 by Z2 can be estimated if Z1 and Z2 are given. Then how to calculate Z1 into Z2? Z1 is 7 plus I by 2. This is 5 minus 14I by this. Just multiply A plus IB, C plus IB. 35 minus 98I plus 5I minus 14I square by 26. I square is minus 1. So you will get 49 minus 93I by 26. So this is how you are supposed to add, multiply and then divide the two complex numbers. So whenever complex number is in this form, try to make this always real by multiplying its conjugate. Don't directly try to middle the problem. You can directly also do it, but usually what happens is you will go wrong when you are calculating. That's why you are advised to first make this real number by multiplying with the conjugate, then proceed like this. See, we will try to find out the algebra of complex numbers by seeing these numerical results. Find the value of I power 140. Find the value of I power 140. So to do this question, I square is equal to minus 1. I cube is equal to I into I square. So minus I, because I square is minus 1. I power 4 is equal to I square into I square. So minus 1 into minus 1 is how much? 1. Right? Okay, followed? Now, I power 5 is I power 4 into I, means I. I power 6 is I power 4 into I square, which is I square, which is minus 1. So, all these things will tell you the following points. I power, let us say, n is equal to minus 1. I power n is equal to minus 1. Otherwise, think like this. I power 4n is always 1. I power 4n is always 1. Why? Because I power 4n is equal to I power 4 whole power n. I power 4 is 1. So 1 power n is 1. So I power 4 n is always equivalent to 1. The next point is I power 4n plus 1 is equal to I. Why? Because I power 4n plus 1 is equal to this. I power 4n is 1, therefore you will get I. Like this. I power 4n plus 2 is I power 4n into I square. I power 4n is 1, I square is minus 1, therefore you will get minus 1. I power 4n plus 3. So I power 4n into I cube. I power 4n is 1. What is I cube? Minus I. So you will get minus I. So you should notice all these manipulations. So I square is minus 1. I cube is minus I power 4 is 1. I power 5 is once again I power 6 is minus 1. Like that. Now observe the first question. See, you divide this with 4. You will get I power 4 whole to the power of. If you divide with 4, what you are going to get? 4 3s, 4 5s. So 1 power 35 is 1. So this is 1. That's it. Had it been, let us say, I to the power of 138. You should first put I power 4. Divide with 4. You will get 4 3s are 12. 4 6s, 4 4s are 16. So 136. So this is 136. So into I square you write. So this is I power 4 whole power 134 into I square. This is 1. I square is minus 1. Like that. Had it been, let us say, I to the power of, you consider 123. Then you have to put like this. I power 4 whole to the power of, divide with 4, 30 into I cube. I power 4 is 1. I cube is how much? Minus I. So this is all minus I. Like that, you are supposed to dispose of the question. Yes, I hope you are following the points. See, square root of minus 36 means square root of 36i plus 3 into I square, sorry. This is 9i square plus 5 into 16i square. This is minus 6i. This is 9i, 3i into 3. This is 20i. So you are going to get 23i like this. 23i. Observe this. You take out I power n outside. We get 1 plus I plus I square plus I cube. Correct. So I power n into 1 plus I minus 1. I cube is minus I. So all will cancel 0. That's it. So you will get 0. So the value of this happens to be 0 like this. Let's solve the quadratic equation. The next question is solving of the quadratic equation. 2 into 1 plus I x square minus 4 into 2 minus I minus 5 minus 3I is 0. This is just like ax square plus bx plus c is equal to 0 form. Ax square plus bx plus a, b, c are complex numbers here. Now, x is equal to minus b plus or minus square root of b square minus 4ac by 2a. Okay, right? Understood? Now, you do one thing. You try to calculate b square minus 4ac separately. B square minus 4ac is equal to 16 into 2 minus I whole square minus 4 into 2 into 1 plus I into minus 5I minus 5 minus 3I. This is 16 into a square 4 plus b square minus 1. A square plus b square minus 2ab. So a square is 4. B square is minus I whole square minus 1 minus 2ab means minus 4a. Yes, understood? Just like a plus b whole square. Only thing is a square 4 plus minus I whole square minus 1 minus I whole square is I square minus 1 minus 2ab means minus 4. This minus sign you take outside, 2 also 8. 8 into 1 plus I into 5 plus 3. This is 16 into 3 minus 4i, 8 into, if you multiply 5 plus 3i plus 5i plus 3i square. 48 minus 64i plus 8 into 5 minus 3, 2 plus 8i. So 48 minus 64i plus 16 plus 64i. 48 plus 16 is 54. Sorry, 64. You got like this. So you got b square minus 4ac, how much? 64. Now you substitute. B is this, so you get 4 into 2 minus I plus or minus root 64 is 8 by 2 into a value how much? 2 into 1 plus I. So finally you can take out 4 outside. 2 minus I plus or minus 2 by 4 into 1 plus I. So x values are, if you take plus 2, 4 minus I by 1 plus I. If you take minus 2, minus I by 1 plus I. So these are your x values. If you want to, you can multiply with the conjugate and make the denominator purely real number like this. So solving of a quadratic equation is just like your real number system. X is equal to minus b plus or minus square root of b square minus 4ac by 2a, can write. So when you are having like this, don't put here and complicate it. You take separately, evaluate, and then substitute is better. You will not go wrong while doing the calculations. See, z is equal to 4 plus I root 7, you have to evaluate this. See, usually what happens is, I never advise you to directly substitute z here and make it complicated. We will plan like this. Z minus 4 is equal to I root 7. Z minus 4 whole square is equal to I square into 7 minus 7. Now this is just like a minus b whole square. So z square plus 16 minus 8z is minus 7. So z square minus 8z plus 23 is equal to 0. You will write like this. So from this is the information for us. Now you divide z cube minus 4z square minus 9z 91 with z square minus 8z plus 23. Divide it. So I think all of you know how to divide. So you can put z here. Z, I have to make this 0. So z cube minus 8z square plus 23z minus plus minus. So you will get 4z square minus 32z. This 4z square minus 23 minus 9 minus 32 plus 91. I have to make this 0. So I have to multiply this with what? 4. So z plus 4. So 4z square minus 32z plus 92. So minus plus minus. So you will get minus 1. Okay. Therefore, z cube minus 4z square minus 9z plus 91. So this is equal to this into this plus this. So you are going to get z plus 4 into z square minus 8z plus 23 plus this. You all of you know this point. Here f of x, let us say here some g of x, here q of x, here r. Then f of x is equal to g of x into q of x plus r. You know this? Now listen, what is the value of this? What is the value of this? You got 0. So you are going to get this is equal to z plus 4 into 0 minus 1. So minus 1. So the value of that happens to be minus 1 like that. So if z is equal to 4 plus I root 7, find the value of this means bring 4 to this side, square on both sides, get a quadratic. You divide this with this quadratic, simplify like this. This is equal to this into this plus this. That's what I got. This remainder here. So z plus 4 into 0 minus 1. Therefore, you will get ultimately minus 1 like this. The next question is x by 1 plus 2i, y by 3 plus 2i, 5 plus 6i by minus 1 plus 8i, x comma y belongs to R. What is x? What is y? See, to do this problem, first you multiply with the conjugate of the denominator. X into 1 minus 2i by Shall I write directly now? 1 plus 4 like this. Plus y into 3 minus 2i by 9 plus 4. 5 plus 6i into minus 1 minus 8i by 1 plus 64. So x into 1 minus 2i by 5. Y into 3 minus 2i by 13. 5 into means minus 5 minus 40i minus 6i minus 48i square by 65. So the LCM is 65. So if we take LCM 13x minus 20, right. 13x into 226xi, 26xi plus 15y minus 10yi is equal to, this is I square minus 1, so you will get 43 minus 46i by 65. 65 you will get 30x plus 15y real part plus I into minus 26x minus 10y is equal to 43 minus 46i. So equate real parts. 13x plus 15y is equal to 43. Minus 26x minus 10y is equal to minus 46. See, this equation is as good as divide with 2. You will get minus 2. 13x plus 5y is equal to 23. This is your equation number 1. This is your equation number 2. Solve the two equations. You do this minus this. You will get 5y is equal to 20. Y is 4. Y is equal to 4 you put here. You will get x value. So 13x plus 20 is equal to 23. 13x is equal to 13. So 13x is equal to 3. X is equal to 3 by 13 like this. Yes, first rationalize, take LCM. Here also rationalize, take LCM. Then you take LCM here. Make it one simple complex number here, one simple compact complex number here. Equate real parts, equate imaginary parts. Try to calculate x and y values like this. So just see the calculations. This is this minus this will give you what? 10y is equal to 20, y is 2. If you put y is equal to 2, this is 10. This is 10. This is 13. So your x is equal to 1. Please correct it. Y is 2, x is 1. The next concept is square root of a complex number. Square root of a complex number. Suppose you come across a problem like this. 7 plus 24i square root. Square root of 7 plus 24i like this. So this you have to assume in this manner. Let us say this is equal to plus or minus x plus iy. Plus or minus x plus iy. Square it. 7 plus square. I square y square means minus y square plus 2xy. This is real part. This is imaginary part. So equate real parts. X square minus y square is 7. 2xy is 24. Xy is equal to 12. X square plus y square whole square. X square minus y square whole square plus 4x square y square. So you are going to get x square plus y square whole square is equal to 49 plus 48. I'm sorry. What is x square y square? 144. So 4 into 1. So 49 plus 576, which is 625. So x square plus y square is equal to 20. You bring this here. X square minus y square is equal to 7. So 2x square is equal to 32. X is equal to how much? 4. X is equal to 4 elements. Already here we wrote plus or minus, so there is no problem. X is equal to 4. Then you subtract 2y square is equal to 18, y is equal to 3. Therefore, square root of 7 plus 24i is plus or minus 4 plus 3i. Square root of 7 plus 24i is equal to plus or minus 4 plus 3i like this. Suppose you come across square root of 7 minus 24i. You assume it as plus or minus x minus iy and proceed. Just like this. You can assume plus or minus x minus iy, square it, proceed like this. Suppose you come across square root of minus 15 minus 8i. Minus 15 minus 8i like this. Then what I am going to do is, I will put it like this. This is 15i square minus 8i like this. I will put plus here and I square. See, my minus sign I am compensating with I square. I can take out I square common. I into square root of, what you are going to observe, 15 plus 8i. Correct? So if both are negative, you plan like this. This is 15i square. This minus sign, you can write I square. I square you take common. Square root of 15 plus 8i you will get. Now, you consider separately this is equal to plus or minus x plus I. Square it. 15 plus 8i is equal to x square minus y square plus 2xyi. X square minus y square is 15. 2xy is equal to 8. X square plus y square whole square is equal to x square minus y square whole square plus 4x square y square. This is 225. This is 64. This is 289. So x square plus y square is 17. X square minus y square is 15. Add 2x square is equal to how much? 32. X is 4. Subtract 2y square is 2, y is 1. So after getting like this, square root of 15 plus 8i is equal to plus or minus 4 plus I you will get. Now, square root of minus 15 minus 8i is I into square root of 15 plus 8i, which is I into plus or minus 4 plus I. Plus or minus I into 4, 4i. I into this is what? I square. So plus or minus minus 1 plus 4i units. Okay, correct? So square root of both negative means you can plan like this. You can take out I square outside, plan like this.